Hi, everyone. Thank you. Thanks for coming. My name is Dan Amanzadi. I'm a software engineer at Google, and I'm also a dedicated triathlete. So on a good week, I'll run 50 miles, I'll bike 100 miles, and I'll maybe write 3,000 lines of code. So maybe it's no surprise that I work on the Google Fit app for Android Wear, which makes really extensive use of the Google Fit platform APIs that we're going to be highlighting for you today.
Hi, everyone. I'm Muzz Mustafi. I'm product manager on the Google Fit platform, and I'm a keen quantified selfer. I enjoy weightlifting, running, yoga, and occasionally experimenting with different diets. Today, we're going to talk about building rich experiences with the Google Fit platform and Android Wear. I'll start out by talking about why we created the Fit platform, what problems we set out to solve, and then Dan will go over its APIs and its data types. Next, we'll look at some specific examples of what you can build with a Fit platform, first basic fitness tracking, and then a more advanced real-time fitness use case. Finally, we'll finish up with some really cool demos coming soon. Need the click. Sorry. Let's start out by introducing the Fit platform. We'll explain why we created Fit, what problems we set out to solve, and why we believe fitness is such a great use case for wearables. Before the Google Fit platform existed, life for a fitness application developer was not easy. It was integration hell. First issue was that of siloed data. Users' health and fitness-related sensor data was siloed across multiple apps and companion devices. Second, there was no easy access and storage of sensor data. No easy way for developers to read, interpret, and record data from health and fitness-related devices, sensors on connected companion devices such as Android Wear devices. The third problem was poor interoperability. There was no simple, standard way for fitness devices to interoperate, so in order to integrate with the existing app device ecosystem, app developers would have to build their own platform and provide an API. Some of these would be poorly implemented, leading to user frustration. With the Google Fit platform, we solve that problem by giving apps one single set of APIs to access, record, and store phone sensor data, wearable data, and other app data. So by using my phone or my Wear device as my fitness hub, I can connect my fitness wearable to my favorite nutrition app and my sleep tracking app to my favorite meditation app. We don't just consolidate data, though. With user consent, we provide low-level sensor recording, and we perform hard computations for things like distance and calories, whether it's resting heart rate from heart rate timestamps, distances fused from your height, steps, and GPS, or calories from heart rate. The Fit platform makes it easier for health and fitness application developers. And fitness and wearables truly go hand in hand. This is for a few reasons. First, the sensors. Your app can get access to all of these ways of measuring fitness activities. Many watches have a GPS sensor, a heart rate monitor, and potentially even a barometer. And because the watch is worn on the wrist, it allows us to detect activities that we couldn't do with a phone being in a pocket or a purse. So that's the first reason, sensors. Second, you can leave the phone. I love my Nexus 6P, but running with the device is a bit cumbersome. I have to rely on infrequent audio cues to find out my current pace, because I can't see the screen when it's in an armband or in my pocket. Third is faster input. When you're on the go, you can have quick interactions with a watch to control music or activity recording that would take much longer if you had to rely on pulling out your phone and opening up the right app. Now, let's talk about what the Google Fit platform provides that enables you to build rich experiences in line with what we just discussed. First, let's talk about the Google Fit app. So here we have the Google Fit app on both phone and on Android Wear. If you're not familiar with the app, you can see that it tracks walking, running, and biking using the Google Fit platform's APIs that detect activity, associated steps, calories, and distances. The app also shows data from connected third-party devices and apps, such as exercise sessions, weight, heart rate, nutrition data, and sleep. Our platform automatically synchronizes between your Android phone, your Android Wear device, and the web. The Fit platform exists in all three of these. So you can write in data via our REST APIs on the web, via our Android SDKs on the phone, or the Android SDK on Wear. The platform handles merging and deduplication of this data intelligently, and we even support takeout integration if the user wants to export their data.
Thanks, Muzz. So now that you've gotten an overview of the Google Fit platform, and maybe some motivation for why it might be a good fit for your fitness app, let me go into a little more detail about the different APIs that it provides. So basically, it breaks down into 4 APIs. First, there's the Sensors API, which gives you access to raw sensor data streams from Android devices and wearable devices sensors, so things like heart rate. Then there's the Recording API. The Recording API does automated storage of fitness data for you using subscriptions. You can subscribe to a data type, and Google Fit will store fitness data for that data type in the background, and it'll persist to the subscription for you. Next, there's the History API, which gives you access to the fitness history and lets you perform bulk operations like reading and inserting and deleting data from the fitness history. And then finally, there's the Sessions API. Sessions are basically a metadata layer on top of raw fitness data that let you store whole fitness activities. So a session is a time interval during which the user was doing, say, a bike ride or a run or a weightlifting session. As far as what you can record, we support really all the standard data types for diet, nutrition, body, activity, sleep. We're also adding this new hydration data type. I think this is a pretty exhaustive list of fitness metrics, but if there's one that's not in here that you'd like to log in your app, you should let us know. So let's start by talking just about basic fitness tracking. You can't measure what you don't track, so tracking and measuring is really, I think, the first step toward motivating people towards better fitness. I actually first started tracking my workouts 10 years ago, back in 2006, when I was training for my first marathon, and I bought my very first wrist-mounted GPS, and it was this massive, ugly, uncomfortable thing, like the size of a chinchilla on my wrist. But it did the job. I could plug it into the serial port on my PC, and I could download XML data of my run. And back then, there weren't any nice portals or kind of fitness platforms. So to visualize my runs, I built this website with Google Maps API 1.0, and I could put my runs up there. And there's something really thrilling for a data geek like me to come back from a workout and analyze all my stats on pace and heart rate and elevation, and I could really track my progress from week to week and workout to workout. So these days, obviously, there are much more elegant and full-featured alternatives where I can analyze my workouts and share them with friends and track my progress toward fitness goals. And also, I don't have to wear a big, giant, ugly thing on my wrist. I can wear this really, these beautiful timepieces from TAG Heuer or Michael Kors, and I can still track and visualize my progress right on my wrist throughout the day with the watch face. Now, this is actually my favorite watch face here, the Fit Cat. Yeah, big ups for Fit Cat. It tries to encourage you to be more active. So basically, if you haven't seen this before, the more active that you are, the more steps you take, the more active the cute little cat becomes. I love how he's wearing the I/O badge and he has the backpack there, and wearing an Android Wear watch also. But actually, so this seems kind of like a simple concept, right? The more steps you take, the more active the cat becomes. But actually trying to build something like this on your own is not easy. There's a lot of stuff you'd have to do if you wanted to do it on your own. You'd have to build a data store that tracks steps. You'd have to turn on sensors, get permission from the user to do that. Then you'd have to be able to record step counts in kind of a way that won't kill the watch battery. If you get that part working, then when the user first installs your watch face, it'll record 0. It'll show 0 because you haven't been recording yet. And then there's all these edge cases, like the user takes off their watch and goes for a walk with just their phone in their pocket. Then you have to write the logic for merging in that data. And then even if you solve all these problems, your step count still is probably not going to be consistent with other watch faces and other apps. So fortunately, we solve all these problems for you with the Google Fit platform. We store steps in the background in a nice low-power, battery-friendly way, and they're ready to be read anytime you like. And you can get consistent step counts on Android Wear with just one method call. So let me just show you how to do that. Typically, when you want to connect to the Google Fit platform, you create a Google API client, right? And normally you create an authenticated one where you specify the account that you want to read data for. So here's how I build the client. I say that I'm interested in reading fitness history data, so I add the fitness history API. I add scopes for the particular types of data I want to read. So in this case, activity type, location, and body sensor data like heart rate. And then next I add an account. So this is the account I want to read the data from. And then finally I add my callbacks, and now I have this authenticated client that I can use to make queries to the fitness platform. But wait, you're saying, Android Wear watches don't have accounts. And this is true. Android Wear 2.0 will actually add account support, but for now, we don't have accounts on watches. Fortunately, there's a solution. Now, you could sync account information from the phone, but this would require your watch face to have a companion phone app, which is a lot more complicated. So here's an easier way to do it without a phone app. You can create a no-account client. So you create a Google API client. As before, we're going to add the history API. And now we just call set default account. We don't specify an account. Finish building it. And now we have a no-account client that we can still use to query step counts. And the way you do that is with the read daily totals method. So you're going to call the history API's read daily total method. And this is basically going to give you a simple way to get step counts for watch face that's going to be consistent with other apps and other watch faces. You can set a callback so that when the result returns, you can process it. So here in the on result, I'm basically just extracting out the step count, putting it into a steps total variable. And there you go. It's a pretty simple way to track steps with your watch face. And it's not just steps that you can get from the Google Fit platform, right? You can also read and write other data like calories consumed. So here's an example of how the LifeSum app displays that data. Here I'm looking at the amount of calories I have left in my budget for the day, 911. So I guess I could eat like 2 avocados and drink 2 glasses of wine tonight. Android Wear 2.0 is going to have a new way to show data on watch faces using complications. Maybe you've seen some of this earlier in the keynote. But basically, on the right, there's a watch face that has 3 complications. And the watch face lets you select which complications you want. And then any app can provide data for those complications. So here's an example where LifeSum is exporting data on calories burned as a complication so that the Ranger watch face, which is on the right, can display it in one of those 3 user configurable slots. And if you want more information on building complications in Android Wear 2.0, highly recommend you check out the talk. There's a dedicated talk at 4 p.m. on this topic.
Another challenge that fitness developers face is how to perform difficult computations. For example, to derive distance traveled from multiple sensor inputs. The user's height, stride length, GPS data, activity type, active time, and step counts all have to be fused in together, potentially across multiple sensor inputs. The Fit platform makes this easy for third-party developers through its advanced transformations for both distance and calories. The Basis app takes advantage of this. Instead of computing distance themselves, they write in steps and activity data into the Google Fit platform and read back our computed values for distance.
Cool, so let's take a look at how we might do something like this with the Google Fit platform. So there are 2 ways of writing data to the platform. You can use the recording API to do live recording, and then you can use the history API to insert activity history. So let's actually start by looking at live recording. All we have to do to start live recording is to subscribe to the data type we care about. So here I'm calling subscribe, and I'm saying I'm interested in activity samples, activity type. And then actually, at that point, I am essentially done. Google Fit will start storing that data that I care about in the background. And so I don't need my own database or my backend to store it. There's no listener needed here. Basically, the Google Fit platform is going to start recording data and syncing it to the cloud in the background. And when I want it later, I can just read it with the history API. So once I subscribe, I'm done. All I really need to do is just check the status code in the on result. And that's just to make sure that the subscription succeeded. Now, let's look at another way of getting data into the fitness history. Suppose I've gotten my data from some external source, like another device. So in the example of Basis, right, they wanted to write in some steps that they had gotten from another device. So first, you create this data source object, and you specify the type of data you want to write. Here, I'm saying I want to write raw step count data. And then you create a data set from the data source, and you add 1 or more data points to the data set. Each of these points has a start and an end time. So here I'm adding 950 steps with a start and an end time. And then finally, you just call insert data to put the data into the fitness history, and that's about it. All you really have to do after that is just basically verify that the operation succeeded before you start querying the data with the history API. And one nice thing is that the Fit platform will actually validate the data points that you insert. So for example, if I put in an invalid time range, or I put in a really unrealistically high calorie burn or cadence or something like that, I'll get an error back in the client instead of the user's fitness history getting all messed up. So here's how this actually looks in the Basis app. They put in steps, And then you can see they are able to derive from that, or through the Google Fit platform, they get this accurate distance traveled.
We've been working hard over the past year to improve the quality of these transformations. The first area with which we've improved them is in relation to distance. Distance computed from steps now has been improved with stride length calibration, from actively tracked walks and runs to improve the quality of passively tracked walks and runs. Secondly, for calories, we will soon be leveraging gender, age, and heart rate as part of our computations to improve the accuracy. Thirdly, for merging, previously leaving your phone at your desk and going for a walk with your Android Wear device would result in your step counts dipping back down and then rubber banding back up. That will no longer be the case through bidirectional syncing. We've also made merging of our GPS data better by prioritizing the highest fidelity GPS sources. Finally, with regards to activities, this is our most complex task, to infer the activity being performed by analyzing multiple sensor inputs in real time. It's really important as users get frustrated when their fitness data has false positive and false negative activities, and they don't get their proper calories and step counts as a result. Fortunately, Google is good and trusted at collecting and understanding complex data through our advanced machine learning capabilities. We've added dynamic sampling of sensor inputs to improve quality, and have made improvements to our algorithms by fusing steps, position, speed, and user corrections together. The result of this hard work over the past year is a reduction in our biking precision error rates from 11% error in early 2015 down to 4% error as of now. And these changes will be rolling out now. Finally, we've added stride length calibration to the Fit platform, which we hope will greatly benefit non-GPS Android Wear devices. So now, if a user goes running, initially with their phone and their watch, which has the phone which has GPS and the watch which doesn't, the two will calibrate together and generate a stride model, and then they'll get accurate distance and pace estimates running without their phone, just with their non-GPS Android Wear device. Now that we've looked at some basic fitness tracking examples, I want to talk about our push this year into real-time fitness tracking. But why is real-time so important when building a motivating fitness experience? Well, when I look at fitness apps out there, and I look at a lot of fitness apps out there, I see that they adopt this framework. They start with the goal of the user. For example, I'd like to lose 10 pounds. I'd like to sleep better. Or I'd like to finish a half marathon. They recognize that in order to accomplish this goal, they need to encourage a pattern of motivating actions so that the user achieves the result that they desire. Let's drill into these motivating actions. There are 3 pillars of wellness: exercise, nutrition, and recovery. Recovery, we mean sleep and meditation. But these pillars do not operate independently, and behavior in one needs to be balanced against the other. By getting a holistic view of what's going on in each of these areas, your app can more intelligently and insightfully present suggestions and nudges based on a changing fitness context in real time. For example, a sleep app might observe that you sleep better when you exercise, or when you eat less sugar in the evening. An exercise app may suggest exercise based on your log nutrition data so that you meet your weight loss goals. Note that in all these cases, timeliness is important. The best time to coach and motivate a user is immediately in response to an action that they have taken in relation to their fitness. So good apps have an inbuilt awareness of the user's overall fitness context. One of our partners, LifeSum, makes heavy use of these principles in their application, and they integrate deeply with the Fit platform APIs, and as a result, they've seen double the retention rate for their users connected to Fit versus their users who aren't connected to Fit. And here are the APIs that we've added to let you respond in real time to a changing fitness context for your user. First, it's real-time data update notifications. It allows you to be notified for certain data types in the fitness store when they change. The second is real-time session notifications. It's actually been in the Fit platform for a while, but we'd like to talk about it today. It allows you to be notified that the user has started or finished a workout tracked in a third-party application. And finally, there's real-time activity recognition, coming soon to Android Wear devices to detect the onset of activity to launch into your active tracking experience. Let's dive into the first API, real-time data update notifications. This allows us to build the following experience. Say I just had an impromptu pizza, and I've exceeded my calorie intake goal for the day. I can get a notification from my weight scale app telling me, listen, more exercise is needed to keep you on track to meet your weight loss goal.
I do admit I have a weakness for pizza, and that one looked pretty delicious. So let's see how we could build something like that example that Muzz just described. What we want to do is subscribe to updates to the nutrition data type. So first thing we do is create a pending intent. This is typically a pending intent for an intent service that's going to call into your app whenever an update to one of these data types occurs. What you then do is you create a data update listener registration request, which is a lot of camel case, but it is a pretty descriptive name. And we're going to pass in the type of data that we'd like to subscribe to updates for. So in this case, nutrition, we're interested in meals that are being logged. And then we pass in that pending intent we created. And then finally, we just call this register data update listener method, and we pass in our client and our request. And then voila, we'll get an update with the next logged meal. And of course, you can register for updates to all different kinds of data types. For example, if I want to be notified every time the user steps on their scale and logs a new weight, I can do that with type weight. And here are actually all of the data types that support real-time updates. Pretty much anything that isn't updated super frequently.
The second API, real-time session update notifications, allows, for example, a nutrition app to be notified that a user just finished a workout session. So say you just finished a weightlifting session, your nutrition app can tell you it's time to get a high-protein meal in to maximize your muscle growth. Or say a hydration logging app. It can suggest rehydrating immediately after finishing a 21-minute run outdoors.
Yeah, it's been so hot here. I think we can all use hydration reminders, even if we haven't been running, just walking around outside. So let's build that one. Similar API to the one that we just looked at with the history API. But here we're going to use the sessions API because we're interested in registering for updates when a session starts or ends. So again, we create a pending intent that we'd like to fire when a new session begins or ends. And then we call this register for sessions method in the sessions API. And now whenever the user starts or ends a workout, the pending intent will fire and an intent will be delivered to our app. And if you want to get more information on that session, you can actually extract it from out of the intent. So here I'm pulling out the start and end time, and then also the type of workout, so whether it was a run or a bike ride or a weightlifting session, and I could put that into the notification like the one that Muzz just showed. One exciting new development that's coming to the Google Fit platform this year is that we're actually going to allow your app to register not only for these explicit sessions that the user initiates, but also for implicit sessions. These are ones that are automatically detected by our platform. So what it means is that your app can respond in real time to a user's fitness activity. So if I just lace up my shoes and I start running, my favorite run tracking app can just start up automatically on my watch. So I'm going to try to show you a demo of how that works. I'm not really properly dressed for running, but I'm going to do a little run around here. OK, I just felt my wrist vibrate, which means that Strava should have started up on my watch. So let's go over here and take a look. And there we go. So you can see that Strava is now recording my run. And I'll post that on Strava later, so I hope you can give me some kudos. Here you go, Muzz.
Awesome. So we've got a couple of three actually, really exciting new features coming on Android Wear towards the end of the year. We've added a beat-to-beat API in Android N. What this allows you to do is get the heart rate timestamps in addition to the BPMs, and compute heart rate variability, which is a proxy for stress levels for the user. Second, we're adding a profile API. This allows you to easily onboard your new users by reading age, gender, height, and weight from the Fit platform. And finally, Goals API, allowing you not only to show, for example, just the step count, but also the progress against that step goal, but also active time, distance, and calorie goals as well from Google Fit. There's another exciting feature that some of you guys might have seen at the sandbox already. So when I go to the gym, I notice that a lot of people are still using an old school pen and paper to log their exercise, their reps, their weight. Seems a bit crazy in 2016. Well, Google Fit on Android Wear did count reps for you for 3 specific exercises: push-ups, sit-ups, and squats, but only if you told the app in advance what you were doing. This is still somewhat limited and cumbersome. Now we've got something better, so I'm going to show you a demo.
Oh, come on, Muzz. Here.
All right, okay, maybe, all right.
Give me a break.
Okay, so I'm going to the Google Fit strength training section, and I haven't told it the exercise I'm about to do.
Come on. Woo! He's working hard for you guys.
As you can see, it detected bicep curls with 100%. And counted the reps. It was 15 pounds, so I'll just lock that. Let's do another exercise, one which involves the legs. Note that I can take some time just kind of setting up.
Very good form.
It's not. Okay, put these down. And you can see it got deadlift.
Yay!
If a rep is missed or an exercise isn't correct, for whatever reason, we will learn from that mistake and become trained to the user's exercise motion. We aim to seamlessly track a whole workout with minimal user input. We're planning an API towards the end of this year, and we're looking for partners.
All right, so that's our overview of the Google Fit platform. Before we wrap up, we just want to thank all of our partners who are already using the Google Fit platform to inspire and motivate people around the world to lead more healthy and active lifestyles. You know, at the end of the day, this talk isn't really about pending intents and broadcast receivers. It's about improving lives and extending lifespans. And so we really hope that you'll be inspired to get out there and build the next generation of awesome, amazing fitness experiences on Android. So thanks so much for your time and attention. Feel free to contact us with any questions. Thank you.